What's up, y'all? And today we're in another video. This is another catalysis video that we're gonna go through. So I'm just gonna go straight into the video. So over here we can see the catalytic cycle for this catalyst, for this rhodium catalyst, and this catalytic cycle is actually an example of the Monsanto acetic acid process. The Monsanto acetic acid process is basically a catalysis reaction used for the formation of acetic acid, and yeah, that's what this is. So in this video, we're gonna focus on how we can determine each of the steps of the reaction of this catalytic cycle mechanism. And so first off, we start off with this rhodium catalyst. This rhodium catalyst, well, let's take a look at it. Overall, it has a negative charge. It has two L ligands attached to it, and it also has two I ligands attached to it. Right? That's exactly what we're looking at. So we start off with this catalyst, and then we initially add methyl iodide, which is this compound CH3I, directly to the catalyst, and then this favors the formation of an oxidative addition reaction. So I'm going to write that down. Oxidative addition. Why is it oxidative addition? Well, it's because the metal itself is getting oxidized, so it gains 2 electrons. Its electron count increases by 2, as well as its ligand bond number. It also increases by 2 because initially we had 4 ligands, and now we have 6 of them because 2 extra ones just got directly coordinated to the rhodium metal center. And so after a typical oxidative addition, you want to go to another process. In another step. In this particular step, we can see a carbonyl insertion or a 1,1 insertion. And what this basically refers to is that you have a ligand. In this case, it's the methyl ligand. You're going to migrate this methyl ligand into the CO, the carbonyl ligand. Into the carbonyl ligand. You're basically transferring this ligand to a different carbon in the structure. So that's what we see here. Initially we had a methyl group straight attached to this rhodium, but now that methyl group has been transferred directly to the carbonyl, right? So initially we had one methyl group and a carbonyl, and now we have the methyl group and the carbonyl. Both superimposed to form this acetyl group, and this is directly forming a coordination to the metal. And so this is what we refer to as a 1,1 insertion reaction. So from there, we add a carbon monoxide ligand to form this reaction. And this step would be a ligand addition, not an insertion, but a ligand addition. And that's because we're increasing the ligand bond number for this complex, because initially we only had one carbon monoxide ligand directly attached to the metal center, but now we have 2 of them. So one here and one there. And then finally we regenerate our catalyst. We regain the catalyst through a reductive elimination, and these steps are typically catalyst regenerating so that we can regain our catalyst and use it for another cycle or for another turnover. So a turnover basically refers to how many times a catalyst is run through a catalytic cycle, and this just basically keeps the catalysis running. And so this step is going to be a reductive elimination. because there is the loss of electrons from the metal center to that. There's the loss of electrons from the metal center, that's why it's reductive. And there's the elimination of two ligands from the metal center. In this case, it's the acetyl group that we were looking at, and then it's also the iodide molecule that we were looking at. And so that's what we lost from this structure. We lost this group, and we lost the one of the I groups, and then that's why it's referred to as a reductive elimination. And essentially, when you lose that group, you're going to regenerate your catalyst for another turnover. I sure hope that was helpful in understanding the steps involved in a catalytic cycle, specifically for the Monsanto acetic acid process. Feel free to post in questions about what you would want me to redo, whether it's an oxidative addition versus a reductive elimination, whether it's a ligand addition versus a ligand dissociation, whatever the case may be. This is to ensure that we increase our understanding in inorganic chemistry, specifically catalysis. So please be sure to leave a like, be sure to leave a comment, even if it's a thank you comment, so that it can boost my content on YouTube. And as always, I'll see you in the next slide.